This is just a video to try and investigate the function y equals a times b to the x just a little bit more. So I've started here with this equation y equals 2 to the x, and what I want to do now is see what happens if I change that b or this a value that's multiplied. And right now a is 1, so it's just 1 times 2 to the x, so we don't really see a as having that much of an effect right now. But notice if I change this base, making the base bigger or further away from 0 is going to make this a steeper curve. And so the steeper this is, the sharper that corner right there to the right of 0 gets really steep, to the left of 0 approaches that asymptote really quick. And as I move further and further down, the closer that gets to 1, remember the shallower that is. So if I'm around 1.2 for my base, that's a really slow growing exponential, but it does eventually start to take off. If I'm less than that, then all of a sudden I get this negative shape. So if this is between 0 and 1, now I get this decreasing value right here. So decreasing curve from left to right going downhill. But notice I'm still going through this point right here at 0, 1. And so anytime that I have this exponential with no left or right shifts, so there's no h or k values that are in here, this is just going to go through the point 0, 1, and then I try to draw my curve from there. Usually this point that's 1 over, around right here, is going to be the b value times the a. So if I plug in x is 1, it's just 0.6 to the first is 0.6. So that's the height of that point right there is 0.6. If I take this back to the 2 to the x, notice that's a height of 2, 1 unit to the right. If I take it up to, let's say, 4, now it's at a height of 4. So you can sort of tell where that's going to be if you move 1 unit to the right of that point there at 0, 1. Now the x is at 1 and the y will just be whatever that base is. Alright, well, let's see what happens now if I go all the way down to 0. So if I try to go down to 0, this again gets steeper. So the closer to 0, the more sharper that curve. The closer to 1, the flatter the curve. Alright, so the closer to 1 it is, the flatter it is. And values less than 1 decrease, values bigger than 1, those are going to increase. Alright, so let's see what happens with that a now. So if I move this a, let's move that up to, let's say, 3. Alright, so now I have 3 times 2 to the x. So this is going to look just like 2 to the x, but everything is going to be multiplied by 3. So it's going to be 3 times higher. The point that I used to have right here at 0, 1, that's now going to be 3 times higher, so right there at 0, 3. The point that I used to have right here at 1, 2, now that's 3 times higher, so now that's at 1, 6. Right, so everything just gets multiplied by 3 if I have that 3 that's out front. Same thing if it's negative, so if I make this a negative 3, now everything is flipped upside down. So the point that used to be right there at 0, 1, now I multiply by negative 3, and now it's at 0, negative 3 for the y value. The point that I used to have right up here at 1, 2 for this 2 to the x, now it's going to be way down here at 1, negative 6, because now I'm multiplying that through by that negative 3. So that's just one way of getting those out. The bigger the a value, the steeper this looks. And you can also tell by this y-intercept right here what's going on. So when I have a is 4, it's going to have a y-intercept of 4. So that point at 0, 1 just gets multiplied up 4 units. If I take that up to 5, now it's y-intercept of 5. If I go down to, say, negative 2, now it's at negative 2, and that's regardless of the base. So whether I have 2 to the x, 3 to the x, anything, that point at 0, 1, let's say I have 7 to the x, that point at 0, 1, it still gets multiplied by negative 2, and the 1 times negative 2 is now just at negative 2. So you can always tell that a value by the y-intercept if you don't shift any left or right, or up or down. Alright, let's go ahead and take a look now with the positive a. So let's try this one. So this would be 7 to the x, and now if I multiply by 2 or 3, you notice that y-intercept is just moving up to 2 or 3 right there. So points I usually try to plug in are where that exponent is 0 and where it's 1 if I want to get sort of a more accurate picture. What I'm going to be looking for is the right shape and where this key point that is at 0, 1 has translated to. So in this case, up here at 0, 3. All right, I hope that was beneficial. Anytime that you're sketching these curves, you can also try to, we'll do one of those real quick. You can also try to base this off of this basic graph here. So if I wanted to do something like, let's go ahead and put in a equation right here. So let's say I have y equals the same sort of thing, 3 times 2 to the x let me just write it down here. So y is 3 times 2 to the x. But then we're going to add, let's say we're going to add 3 at the end. All right. So there's that same curve, but now just shifted up 3. And so this asymptote that was at 0 is now going to go up 3. Everything else, this point that was at 0, 3, now moves up to 0, 6. All right, so that whole curve that I used to have 3 times 2 to the x, I just add 3, whole thing shifts up 3. So anytime you're graphing these functions, a lot of times that's what I'll do is just graph this basic a times b to the x, and then look at how that's shifted left or right, or up or down. All right, so if you have any more questions, please let me know, and hope this was helpful.